Good morning, students. Welcome to the lecture 56 of fluid mechanics subject. In the last class, we have discussed about the classification of orifices and basic formulas regarding the orifice problems. Today in this class, we will discuss about the flow through large orifice, small orifice, and other mixed orifices. Right? Okay. So we'll start the class. We have completed the classification of orifices, small orifice and large orifice, and related problems in this concept. Okay, yes, so we shall continue the 55th lecture, the problems what we have discussed in the previous session. We'll continue the previous session classes. So, the problem, fifth problem we are dealing, the water discharge at a rate of 98.2. So, the volume, the discharge of water Q is 98.2 liters, that is 0.982 meter cube per second, through a 120 meters 120 diameter vertical orifice. So what is the diameter of the orifice? D is equals to 120 meter. Under a constant head of 10 meters, a point on the jet measured from the vena contracta of a jet has 4.5 meters horizontal and 0.54 meters vertical. Find the CV, CC, CD of the orifice. So you may get this type of problems in the external exam. So the marks allotted for this problem may be 6 marks or 7 marks, right? Now we will see the solution. Write the first given data. The discharge Q is equals to 98.2, that is 0.0982 meter cube per second. Then what is the diameter of the orifice? The diameter of the orifice is 0.12 meter. Then what is the area of the orifice? Area is equals to pi d square by 4, that is 0.01131. Then what is the head of the orifice? That is 10 meters. Okay. Then what is the contractor horizontal? X is equals to 4.5, Y is equals to 0.54. Now the theoretical velocity is equals to V theoretical is equals to root 2 GH, right? Then substitute the values here, you are getting the answer. Then theoretical discharge Q theoretical is equals to V theoretical into area of the orifice. So V theoretical into area of the orifice, that is equals to 0.1583 meter cube per second. The value of CD is equals to actual discharge by theoretical discharge. What is the actual discharge? Q by Q theoretical, that is equals to actual discharge by theoretical discharge, that is 0.62. Then the value of the equation CC is given by CV is equals to X divided by 4 root of 4YH. Then 4.5 divided by root 4 into 0.54 into 10. Got it? Into 10. The value of CC is given by the equation CC is equals to CD by CV. That is equals to 0.62 divided by 0.968, that is 0.64. That is 0.64. Then we got CV, we got CC. Then what is CD? Oh, sorry, CD also, we got the answer, right? So very simple problems based upon the direct formulas what we have doing. Next, a 25 meters, a 25 diameter nozzle, 25 diameter nozzle discharges Q is equals to 0.76 meter cube per minute when the head is 60 meters. The diameter of the jet is 22.5 mm. Determine the values of coefficients CC, CV, and CD. The loss of head due to the fluid resistance. Then the diameter of the nozzle D is equals to this one. Then what is the Q actual discharge? Q actual is equals to 0.76 meter cube. That is equals to meter cube per minute కాబట్టి 0.76 divided by 60, that is equals to this one. Then what is the head, what is the head of the container? 60 meters. Then what is the diameter of the jet? 22.5 meters. This one. Okay, so this is nozzle, this is a flow of water. Flow of water. Then the values of coefficient of contraction CC is given by coefficient of contraction CC is given by area of jet divided by area of nozzle. Then area of jet is equal to pi d square by 4, that is pi d square by 4. Therefore cancel pi d square, uh, pi by 4, pi by 4. You are getting d square by d square. What is the diameter of the nozzle? This is the diameter of the jet. Then what is the area of the nozzle? This is the area of the nozzle. Therefore this is 0.81. Then coefficient of discharge CD is given by actual discharge by theoretical discharge. Then substitute the values. Actual discharge, what we got, the actual discharge point 0.1267 divided by theoretical discharge, that is theoretical discharge is equals to root 2 GH into area of the nozzle. Therefore actual divided by root 2 GH into pi d square by 4. Therefore the value root 2 GH into pi d square by 4. The value is this one. Then we got the value CD. Then what is CV? The CV is given by CD by CC. So already we got the CD value, right? We know the CC value. Substituting here, we are getting the answer. Then what is the second thing you have to find? Loss of head due to the fluid resistance. Loss of head due to the fluid resistance, right? Therefore, applying the Bernoulli's equation at the outer nozzle to the jet of the water, what we are getting? This one. So the formulas what you already used in some other unit and third unit. Now, pressure energy plus kinetic energy plus datum energy is equals to pressure energy plus kinetic energy plus datum energy plus loss of head. Why? Because you are using loss of head concept. Therefore, P1 by rho g is equals to P2 by rho g. So V1 square by V2 square, V1 square by 2g, V1 square by 2g. Okay, that is equal to pressure head. Z1 is equal to Z2. That is the datum line. V1 is equal to root 2gh. V2 is equals to area of the velocity, that is CV root 2gh. Now, so what is this pressure P1? Root 2gh square divided by 2g. This one. V1 V is equals to root 2gh square divided by 2g is equals to root 2gh into CV divided by 2g plus loss of head. Then what is the head? Head is equals to, so మనం క్యాన్సిల్ చేసుకోండి, root 2g 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 h is equals to CV square into h into plus loss of head, that is equals to h minus CV square into h, that is equals to h of 1 minus c square. Now 60 of 1 minus 0.928 square is equals to 8.328. 8.328, that is the answer, right? Understood? So simply by using loss of head అని వచ్చినప్పుడు directly we have to take the Bernoulli's equation concept. Now next problem. So very simple problems, straightforward problems. That's why you have to practice number of concepts. In the unit 4, so majority are having very less concepts of theory and more concepts of problems. Thereby focus more on problematic concepts. Okay. Now a closed vessel contains water up to the height of 1.5 meter, and over the water surface there is air having a pressure of 7.8 above the atmospheric pressure. At the bottom of the vessel, there is an orifice of diameter 100 mm. There is an orifice of a diameter 100 mm. Find the rate of flow of water from the orifice, taking the value CD is equals to zero point 0.6 value. So what is saying that a closed vessel contains a water up to the height of 1.5 meter. Over the water surface there is a air. Pressure ఎంత ఉంది? This water surface పైన air ఉంది. దాని pressure ఎంత? 7.4848 Newton per centimeter square. Above the atmospheric pressure. At the bottom of the vessel, you are having a small orifice. The diameter is 100 mm. Just find the rate of flow of water from orifice. Now, write the given data. What's the given data? The height h head is equals. Here, the height of water is equals to 1.5 meter. Then the diameter of the orifice is 100 mm. That is 0.1. Then what is the value of CD? 0.6. Now the air pressure P is equals to 7.848 given in the problem. Now applying the Bernoulli's equation at section 1 and section 2. Why? Because at the atmospheric level that is a section 1, at the orifice level that is a section 2 we are having. Therefore level 1, level 2. Therefore applying the Bernoulli's equation, pressure energy plus kinetic energy plus datum energy is equals to pressure energy plus kinetic energy plus datum energy 2. Therefore, the datum energy passing through 2, which is very close to the bottom surface of the tank, right? Bottom surface of the tank. Therefore, Z2 is equals to 0, Z1 is equals to, and the height on the 1.5 meter long. Now, P2 by rho G is equals to 0. Why? Because it is at the atmospheric pressure at 2 is 0. Then at 1 is equals to 7.848 to 10 to the power of 4 divided by 1000. Rho means 1000, G means 9.81. That is equals to 8 meters of water. Now 8 plus 0 plus 1.5 is equals to 0 plus v square by 2 by 2g plus 0. We are getting the value 9.5 is equals to v square by 2g. Now v2 is equals to root 2 g into h. That is equal to this one. Now the rate of flow of water is equals to CD into A2 into V2, rate of flow of water. Now CD already is in the question. A is equals to area pi d square, that is zero point 0.1 square into V2 value 13.652. So finally we are getting the answer is 0.0643 meter cube per second. So that is the thing for getting the rate of flow of water. So it is also very important problem. Next, a closed tank, a closed tank, a closed tank partially filled with water up to the height of 0.9 meter, having an orifice of 15 mm at the bottom of the tank. The air is pumped into the upper part of the tank. Then find out the pressure required for a discharge of 1.5 liters per second through what? Through the orifice. Take CD is equals to 0.062. Okay, now write the given data. The height of water is equals to h. Height of water h is equals to 0.9 meter. Orifice is equals to 15 mm. What is the orifice? D is equals to 15 mm, that is 0.015 meter. Now the air is pumped into the upper part of the tank. So find out the area pressure required for a discharge of 1.5 liter per second through the orifice. What is the pressure here? 1.5 liter. Q is equals to discharge is equals to 1.5 liters per second. So we know the H value, we know the D value, then find area A. A is equals to pi d square by 4, that is pi by 4, d square is equals to 0.015 square, that is equals to this one. Now the discharge Q is equals to this one, CD is equals to 0.62062, then let P is equals to pressure intensity. Therefore, the pressure head of the air, the pressure head and pressure energy, that is P by P square by 2G. That is sorry, P by 2G. That is equals to P into 10 to the power of 4 divided by rho is equals to 1000, G is equals to 9.81. Therefore, 10 P by 9.81 of water, right? Now, V2 is the velocity at the outlet of the orifice. So what you have to take, V2 is equals to root 2GH. ఈ హెచ్ నెల రాస్తున్నాము హెచ్ ప్లస్ ప్రెషర్ ఎనర్జీ that is 2 into 9.81. H is equals to 0.9 plus 10p by 9.81. Now the discharge Q is equals to CD into A, root of CD root 2G into H plus this formula, H plus P by rho G, H plus P by rho G. Got it? So CD is equals to root 2 into H. Now substituting the values, Q వచ్చేసి CD is equal to 0.6, A is equals to this one, root 2 into 9.8 into H ante 0.9, P by rho G. Now calculating this one, so keep on calculating this one, right? So doing calculations, finally we got pressure is equals to 9.30 T. Therefore, pressure P is equals to 9.3 into 9.81 divided by 10. It is equals to 9.125 Newton per centimeter square. Right? Next one. Flow through orifices. Flow through large orifices. Next concept is flow through large orifice. If the head of liquid is less than 5 times the depth of the orifice, so that is a definition what you are discussed in the earlier slide. Starting slide lo discuss cheskunnam kada. If the head of a liquid is less than 5 times the depth of the orifice is called as large orifice. In case of small orifice, the velocity in the entire cross section of a jet is considered to be the constant, and the discharge can be calculated by Q is equals to CD into A into root 2GH. Okay, then the velocity is not constant, then Q can be calculated. Q is equals to CD into A into root 2G into H. Got it? Next. Then the discharge through the rectangular orifice, the flow through large orifice. Next one, in that large orifices, we are having different types of surface areas. So in the syllabus, we are discussing about the rectangular orifice, the circular orifice, the triangular orifice. Got it? Now, the discharge through large rectangular orifice. Okay, na? Now, considering a large rectangular orifice in one side of the tank, one side, maybe any side, right side, left side, or whatever it is, discharging freely into atmospheric pressure under a constant head. Now, from this figure, this is a container. So, this orifice, this is a head level H1, the head level H2, and the average head H. Now, H1 is equals to height of a liquid above the top edge of the orifice. Just by seeing the figure, you can write on your own. H1 and enti above the edge. H2 height of a liquid above bottom edge of an orifice. Next, D is equals to breadth of the orifice. Now, D is equals to the depth of the orifice, that is H2 minus H1. Right or wrong? Depth of the orifice H2 లో నుంచి H1 తీసేస్తే we are getting the depth of the orifice. Now, CD is equals to coefficient of discharge. Now, considering the horizontal axis, the strip of depth DH, and below H, the vertical surface of a liquid which is in the container. Okay, so this is the next details what you have to consider for a large rectangular orifice. Therefore, considering the area of the strip, area is equals to length into height, length into breadth, that is B into D into H. Now the theoretical velocity strip is equals to, as usual, root 2 G into H. Now the discharge through the elementary strip, elementary strip here, the discharge through this elementary strip, the discharge through this elementary strip is given by dq is equals to cd into area of the strip into velocity. Okay, cd into area of strip into velocity. So what you have to do, cd as it is, area is equals to b into 2h, velocity is equal to root 2 gh. Now substituting, we are getting cd of b into root 2 gh into dh. By integrating the above equation between the limits h1 and h2, the total discharge through the whole orifice is q is equals to integral h1 h2 cd into b into root 2 gh into dh. So after getting integration, we are getting q is equals to cd into b into root 2 g of h1 h2 into h into dh. So substituting cd into b into root g, brackets lo h 3 by 2 by 3 by 2. So after solving this problem, or solving this equation, solving this process, we got 2 by 3, 2 by 3, 2 by 3 CD into B root 2 G H2 minus H1, right? This is the diameter of the large orifice, diameter of through the large orifice. Now, based upon this formula, we will do some problems. Okay. Now, take the first problem under this large orifice. Find the discharge through the rectangular orifice. So before doing the problem, first to see the question, what type of orifice it is given, especially in the unit 4. Rectangular orifice ichara, circular orifice ichara, or triangular orifice ichara. Based on that only you have to do the problem. So the rectangular orifice 2 meters wide, 1.5 meter deep, fitted to a water tank. The water level in the tank is 3 meters above the top edge of the orifice. Take CD value and find the discharge of the rectangular orifice. Now, what is the width of the rectangular orifice? 2 meters. What is the depth of the orifice? 1.5 meter. Then the height of water about the top edge of the orifice h1 is equals to 3 meters. h1 is equals to 3 meters. Idi the top h. Now, the height of water above the bottom edge of the orifice h2 is equals to h1 plus d. Then what is h1? 3 plus 1.5, 4.5. And also question name ichadu CD value is 0.62. Now the discharge is given by ఇందాక మనం చెప్పుకున్న this apply here. That is Q is equals to 2 by 3 CD into B into root 2 G into H2 minus H1. Now 2 by 3 into 0.62 into 2 into root 2, so on. So we are getting, after substituting all the values, finally we are getting this 15.917 meter cube per second. So very simple and straightforward problem. Okay, now next problem. 7.12. Next problem. A rectangular orifice 1.5 meter wide, 1 meter deep, discharging water from a tank. If the tank level is 3 meters of the edge of the orifice, find the discharge through the orifice. Take the coefficient of discharge is equals to 0.6. Now, width of the orifice B is equals to 1.5 meter. Width of the orifice B is equals to 1.5 meters. Depth of the orifice D is equals to what is the depth here? 1 meter is given. What is the value of CD? The height is equals to H1. H2 is equals to H1 plus D, that is 3 plus 1, that is 4. What is the value of CD is given? The coefficient of discharge CD is equals to 0.6. Now applying this formula, Q is equals to, this is the formula. Applying the formula, Q is equals to 2 by 3 into CD into B into root 2 G H2 minus H1. Factoring the values, 2 by 3 into CD into 1.5 into root 2 into 9.81. Common గా తీసుకొని 4 minus 3. After keep on substituting, we got the final value is so slow. Right? So direct formula calculations, we are getting the answer. Now, next problem. A rectangular orifice 0.9 meter wide, 1.2 meter deep is discharging water from a vessel. The top edge of the orifice is 0.6 meters below. Calculate the discharge of the orifice CD. The percentage error of the orifice treated as small orifice. Okay, na? Now, width of the orifice is equals to 0.9 meter. The depth of the orifice is equal to 1.2. The height is equals to 0.6. Then the H2 is equals to H1 of this one H1. H2 is equals to H1 plus D, that is 0.6 plus 1.2, that is 1.8 meter. Now CD is given as 0.6. Now the discharge is taken as this one. Apply this formula. After substituting this one, we are getting the value of discharge Q is equals to 3.1. Now, determining for small orifice, this is a formula. Large orifice ki the small orifice ki e formula, right? This is for large orifice, this is for small orifice. Q is equals to CD into A into root 2GH, where H is equals to H1 by H1 plus D by 2, that is 1.2. A is equals to B into D, that is 0.9 into 1.2. Therefore, Q1 is equals to CD value పెట్టండి, A పెట్టండి, root root 2G into H. So substituting these values, Q1 is equal to 3.1. Therefore, the coefficient of discharge, therefore the percentage error is equals to Q1 minus Q divided by Q. What is the Q1? 3.1. What is the Q value? Q value is 3.107. That is the efficiency what we have obtained. It is a percentage of efficiency. That is percentage of error is equals to Q1 minus Q by Q. That is 3.14 divided minus 3.1 divided by 3.1. That is 1.109 percentage. Got it? Now, next concept is the discharge through the fully submerged orifice. Means whenever the outer side of the orifice is not open to atmosphere and it is filled in the other tank, that is the discharge through the fully submerged orifice. That is the concept in the unit 4. That is the other concept. Okay. Now, from the figure, you can assume or simply observe that you are having two water tanks, right? You are having two water tanks, it is individual to design, or you are having a partition in the tank. Okay. So, considering a two volumetric tank, okay. So, you are having an orifice at one end of the tank, which is at the center or top or bottom, but here you are having just below the center. Okay, now this is orifice, right? So from the orifice it is a height, there is a the atmosphere is H, inside this is H1, inside this one is H2, right? Now H1 is above the head of the second tank, H1 is equals to initial head of the first tank, H2 is equals to bottom head of the first tank. So the layers at 1 and at 2, got it? Fully submerged orifice is one which has its whole of the outlet side submerged under a liquid so that the discharges of jet liquid into the some kind of the liquid. It is also called totally downward drowned orifice. It shows as fully submerged orifice. Consider the 2 points 1 and 2. Point 1 being in the reservoir of the upstream side and point 2 being in the vena contractor surface. Okay, vena contractor. Therefore, H1 is equal to height of water above the top of the orifice on the upstream side. H2 is equal to height of water above the bottom of the orifice. H is equal to difference in the water level. H is equals to difference in the water level, that is H2 minus H1. Now B is equal to without the orifice, CD is equal to coefficient of discharge. Then the height of water above the center of the orifice of the upstream is given by H plus H2 minus H1 by 2. That is equals to H1 plus H2 divided by 2. Now the height of water above the center of the orifice on downward stream is equals to H1 plus H2 divided by 2 by minus H. Now equating 1 and 2 we get applying the Bernoulli's equation at 1 and 2 we are getting pressure energy plus kinetic energy is equals to pressure energy at section 2 and kinetic energy at section 2. Here it is in a straightforward base structure. The datum energy Z1 is equals to Z2 is equals to same. Now P1 by rho g is equals to H1 plus H2 by 2. P2 by rho g is equals to H1 plus H2 by 2 minus H, where V1 is negligible. Why? Because we are not considering the volume, that is kinetic energy. Now H1 plus H2 divided by 2 plus 0 is equal to H1 plus H2 divided by 2 minus H plus V square by 2g. Now V square V2 whole square divided by 2g is equals to H. Therefore, V2 is equals to root 2 GH, that is P into H of that is V2 is equals to root 2 GH. That is area is equals to B into H2 minus H1. Diameter through the orifice CD is equals to diameter through the orifice is equals to CD into area into velocity, that is CD into B into H2 minus H1 into root 2 GH. So keep on substituting CD into B, H2 minus H1 into root 2 GH. So this is a discharge of fully submerged water. So we will do one problem and we will discuss in the other class. Okay. Now find the discharge through a fully submerged. Definitely question this type of question you will get in the exam. Okay. Find the discharge through fully developed submerged orifice at a width of 2 meters with the difference of water levels on the both sides of the orifice is 50 centimeters. The height of our water from the top and bottom of the orifice is 2.5 and 2.75 meter respectively. Okay. Now take CD is equals to zero point 0.6. Right? Now the width of the orifice B is equals to 2 meters. The difference of water level H is equals to 0 0.5 meters. The height of water H1 is equals to 2.5 meters. The height of water H2 is equals to 2.5 meters. The value CD is given as 0 0.6. Then what is the thing you have to find? Discharge of the submerged orifice is given by this 7.9 equation for this is the formula. Q is equals to CD into B into H2 minus H1 into root 2 GH. So directly substituting the value CD value, 2 value, 2.74 minus 2.5, root 2 G into H. So finally we are getting the answer is 0.9396 meter cube per second. Meter cube per second. Got it? Next. Same problem. Find the discharge through the so అందుకే ఈ problems లో whenever you are studying or reading the question in the exam, see it is rectangular or triangular or circular or it's a fully submerged or partially submerged. Now the discharge through the totally drowned orifice 2 meters wide. Totally drowned అన్నా కూడా fully submerged అన్నమాట. 2 meters wide and 1 meter deep. If the difference of water levels on the both sides of the orifice is 3 meters, take CD. The width of the orifice is B. The depth of the orifice is D. The difference of water levels on the both the sides H is equals to 3 meters. CD is equals to 0.62. Then the discharge of the orifice CD is equals to area into 2GH. Area into 2GH. Therefore, area CD, we know the CD value. Area is equal to length into breadth into root 2 GH. So we got B is equals to 2, D is equals to 1, root 2 into H is equals to 3 meters. Simply and directly we got the value 9.153 meter cube per second. So this is a other way of considering the problem. So now in this today's class, we have discussed some of the problems related to the initial slide, 55th lecture slides, and we have discussed about the classification of large orifices and related problems, and also the concepts of fully submerged water bodies in the tank. So in the tomorrow's class, we will discuss about discharge through partially submerged orifice. So fully అయిపోయింది. Tomorrow we'll discuss about this concept, right? So with this, I'll wind up the class. So I'll upload this video in the channel. Later you subscribe it and watch the videos whenever you find time. Got it? So with this, we'll wind up the class. So thanks for listening the class. Have a good day.